Hi friends, today I will explain you exercise number 8.1. So let's do it. Question number 1. In triangle ABC, right angle at B. That means our B is equals to 90 degree. So give name A and C to our other vertex. We can also draw the triangle like this. That means B here we can give A here and C. Okay, so our B is equals to 90 degree and name A and C we can give to any vertex. Okay, now AB is equals to 24, AB is equals to 24 centimeter, BC is equals to 7 centimeter, BC is equals to 7 centimeter. Determine sine A, cos A, sine C and cos C. Okay, so AB 24, BC 7 centimeter, sine A, sine C, cos C we need to find. Now what is the formula of sine and cos? Sine theta is equals to opposite side upon hypotenuse and cos theta is equals to adjacent side upon hypotenuse. So here our hypotenuse is equals to C, AC, right? AC is our hypotenuse. So first of all we need to find our hypotenuse AC. Okay, now I know other two sides, that means AB and BC, so I can find my third side by using Pythagoras Theorem. So first of all, by Pythagoras Theorem for triangle ABC, now what is Pythagoras Theorem? Hypotenuse AC square is equals to sum of square of other two sides, that means AB square plus BC square. AB is equals to 24, so put 24 in place of AB and put 7 in place of BC. Now 24 square, that means 24 multiplied 24, it's a 576, right? And plus 7 square 49. Now addition of 576 and 49 is equals to 625 centimeter square. Now for finding out AC, take square root. So AC square is equals to 625, then square root of AC square is AC and square root of 625 is 25, and here centimeter square is there, so in square root it is only centimeter, so AC is equals to 25 centimeter, right? Now use the formula of sine and cos. First of all we need to find sine A. Now sine A, that means our A is reference angle. Now what is the formula of sine theta? It is the opposite side upon hypotenuse. Here angle A is given, that's why side opposite to angle A divided by hypotenuse. Now opposite side for A, it is BC, so BC, and hypotenuse is AC, so BC upon AC. Now put the values of BC and AC. BC is equals to 7 and AC is equals to 25, so 7 by 25, and all the trigonometric ratio does not have any unit because it's a ratio. Okay, so only 7 upon 25. Then cos A, again A is our reference angle. Now formula of cos, adjacent side upon hypotenuse, so side adjacent to angle A upon hypotenuse. Now adjacent side for angle A, it is AB and hypotenuse AC, so AB upon AC, and put the value of AB and AC. AB is equals to 24 and AC is equals to 25, so final answer cos A is equals to 24 by 25. Now sine C. Now in this time our reference angle is C, so sine C, that means side opposite to angle C upon hypotenuse. Opposite side for angle C, it's AB and hypotenuse AC, so AB upon AC, put the value of AB and AC, so it's a 24 by 25. Then same way cos C. Now for cos, formula is adjacent side upon hypotenuse, so side adjacent to C, it's a BC, upon hypotenuse it's a AC. Now put the value of BC and AC, it's a 7 upon 25. Okay, so with sine, cos, tan, all the trigonometric ratios, some reference angle is given. We need to take our opposite side and adjacent side according to that angle. Okay. Question number 2. In the given figure, find tan P minus cot R. So we need to find first of all tan P and cot R, and then we need to subtract it, right? So first of all tan P. Now what is the formula of tan P and cot R? Means tan theta and cot theta. Opposite side upon adjacent side, right? So here one side is given but QR is not there. So first of all we need to find that QR. Now I know the two sides of right angle triangle, so I can use Pythagoras theorem and I can find my third side. So first of all, by using Pythagoras theorem for triangle PQR, hypotenuse PR square is equals to PQ square plus QR square. Now PR is equals to 13. So here 13 square is equals to PQ 12. So 12 square and QR as it is because we are finding it. So for finding out QR, first of all 13 square is equals to 169 and 12 square is equals to 144. Then for finding out QR square, transfer this 144 to left hand side. So QR square is equals to 169 minus 144. Then 169 minus 144 is equals to 25 centimeter square. So here QR square is equals to 25 centimeter square. Now take square root. So QR is equals to square root of 25, 5 centimeter. Right? So QR is equals to 5 centimeter. Now use the formula for tan P. Now tan P, this time our reference angle is P. And formula of tan theta, it is opposite side upon adjacent side. Now opposite side for P, it's a QR, and adjacent side for P, it's PQ. So QR upon PQ. Now put the values of PR and put the values of QR and PQ. So QR is equals to 5 and in denominator PQ is equals to 12. So 5 upon 12. Then cot R. This time our reference angle is R. For R, opposite side PQ, formula of cot is equals to adjacent side upon opposite side. So first of all adjacent side for R, it's a QR. So QR in numerator and in denominator opposite side. Opposite side means PQ. So QR upon PQ. Again we got 5 upon 12. Now final process tan P minus cot R. Put the value of tan P and cot R. Both are is equals to 5 upon 12. So 5 upon 12 minus 5 upon 12 plus and minus. So it's a 0. Okay, 5 upon 12 minus 5 upon 12, 0. Question number 3. If sin A is equals to 3 by 4, then calculate cos A and tan A. Here one ratio is given. It is a sin A is equals to 3 by 4. Previously in question number 1 and question number 2, sides are given. So there is no issue. Here sides are not given but one ratio is given. And from that ratio we cannot find our sides directly. Okay, from the ratio we cannot say that our side is 3 and 4 because our side may be 6 upon 8, otherwise 9 upon 12, otherwise 12 upon 16. If you simplify this all the three ratio, you will get 3 by 4. So maybe your sides 6 and 8, maybe your sides 9 and 12, maybe your sides 12 and 16. Okay, so from ratio we cannot directly say that the value of our sides. But one thing is that these all are the equivalent rational number, right? That means whatever number multiply with numerator, same number will be multiplied by denominator. Means if I write 3 by 4 and multiply 2 by 2, then I get this ratio, that means 6 by 8, right? Finally our ratio is same, so whatever number is multiplied with numerator, same number will be multiplied by denominator, because how we can get this ratio? We multiply numerator and denominator by 3. 3 3s are 9, 3 4s are 12. For this ratio, we multiply numerator and denominator by 4. 3 4s are 12, 4 4s are 16. Okay, so one thing is common, that is whatever number is multiplied with numerator, same number will be multiplied by denominator. So we don't know that number by which number it is exactly multiplied. So for that we use k, 3k and 4k. Okay, k is any integer number, sorry, any positive integer number. Okay, so we use k. So we can say that our numerator, that means sine theta, sine a is given. So numerator is opposite side, because formula of sine theta, it is opposite upon hypotenuse, right? So we can say that our opposite side is equals to 3k and hypotenuse is equals to 4k. That means if any ratio is given, on that time we need to write like this, means 3k 4k, we need to put k. Okay, if you do not use this k, then even you will get this right answer, but we need to write correct thing in our answer sheet. Only answers doesn't matter, our method should be right. So that's why we need to use k here, because we cannot directly find the sides from ratio. For that we need to put k here. At last this k definitely will be cut. Okay, so our numerator, that means first of all formula of sine a, again I'm writing this, opposite upon hypotenuse. So in numerator it is equivalent to opposite, so opposite of a, it is bc, so I take bc is equals to 3k. Okay, and denominator hypotenuse is there, so denominator it's a 4, so hypotenuse AC is equals to 4k. If sides are given, then we do not need to use this k. Okay, if ratio are given, then on that time we need to use this k. So our two sides is BC is equals to 3k and AC is equals to 4k. Now find our third side by using Pythagoras theorem. Now what is the Pythagoras theorem? So hypotenuse square, that means AC square, is equals to sum of square of other two sides. So AB square plus BC square. Now from this equation we need to find our AB. So transfer BC to the left hand side. So what you get, that is AB square is equals to here AC square as it is and plus BC square. If we transfer to the left hand side, it becomes minus BC square. Then for finding out AB, take square root from both the side. So square root of AC square minus BC square is equals to AB. So this formula we use here. AB is equals to under root AC square minus BC square. And put the value of AC and BC. So here, first of all, using the Pythagoras theorem and this formula. So AC is equals to 4k and BC is equals to 3k. So find out square. So 4k square, it's a 16k square. Then negative sign. 3k all square, it's a 9k square. Right? Then subtract this 16k square minus 9k square. It's a under root of 7k square. Now square root of k square, it's a k, and under root 7 as it is. So under root 7k. Now find out this cos A. So cos A means adjacent side. For A, adjacent side is AB divided by hypotenuse. Right now hypotenuse is AC. So put the value of AB and AC. AB we got here under root 7k divided by AC, it's a 4k. So kk cut. So we get answer under root 7 by 4. Then tan A. We can find a tan A by using the formula sin theta upon cos theta. But here we can use, here I am using sides. Okay, so for tan A, opposite side. Right now opposite side for A it's BC. Upon adjacent side it's AB. So BC upon AB, then put the value of BC and AB. So BC is equals to 3k, and AB we get under root 7k. So our k cut. So finally we get 3 upon under root 7. So our 10a is equals to 3 upon under root 7. Now we are solving this question by the second method. Okay, so if we do not want to do this, then we have one more method. It is, we know the formula of cos A. We know one identity, sine square theta plus cos square theta is equals to 1, and from that we are deriving one formula, that is cos square theta is equals to transfer sine square theta to the right hand side, so 1 minus sine square theta. And if we want to find cos theta, then we can take square root. So in square root 1 minus sine square theta. So this formula we can use here. Okay, so you just use it. So cos A is equals to under root 1 minus sine square theta. So 1 minus, now sine theta, and square root sine theta is equals to 3 by 4. So square of 3 by 4, it is equals to 9 upon 16. Now take LCM. So 16 1 is 16 minus 9. 16 minus 9 upon 17. 16 minus 9, it is 7. So I am right here under root 7, and in denominator 16 square root, it is equals to 4. So directly we got cos A is equals to under root 7 by 4, right? And if we have the value of sine theta and cos theta, then we can get our tan theta. So tan A is equals to sine A upon cos A. This formula we also learn in our theory part. So put the value of sine and cos. Now sine A is equals to 3 by 4, and cos A, right now we got under root 7 by 4. So denominator cut. So finally we got 3 upon under root 7. We can also use this method. Okay. Question number 4. 15 cot A is equals to 8. Find sine A and sec A. One thing I forgot to tell you in question number 3, that is, here all the values are given in terms of angle A, right? So whenever you make triangle, then keep one thing in your mind, your A cannot be your right angle. Okay, so you can put A here, otherwise here, but you cannot put A in place of right angle. Okay, so first of all we put A here, then any angle we can write in any place, B or C. Right now I am giving B to the right angle and other angle is C. You can change the place of B or C, not an issue, you get same answer. Okay, then 15 cot A is equals to 8. Now what is the meaning of this? 15 cot A is equals to 8. So you can find cot A from here, transfer 15 to the right hand side, so it goes in denominator, so 8 upon 15. Now what is the formula of cot? It is adjacent upon opposite. So your adjacent 8k and opposite 15k with respect to A. A is your reference angle. First of all, adjacent it's a 8k, and then opposite it's a 15k. Okay, so let AB is equals to 8k and BC is equals to 15k. First of all we need to find that cot A, and from that let AB is equals to 8k and BC is equals to 15k. We need to remember that all the 6 trigonometric formula. Okay, then two sides we know, AB and BC. So for third side use the Pythagoras theorem. Now third side AC, that Pythagoras law is a hypotenuse square AC square is equals to AB square plus BC square. Here we try to find AC. Okay, so take square root of this equation, that means AC square becomes AC, and here square root of AB square plus BC square. And one more thing, you cannot write like this, under root AB square plus BC square. It's wrong. Here you are taking square root of both the side, so you cannot give separate square root to each term. You need to write like this. Okay. Now put the value of AB and BC. Your AB is 8k, BC is 15k, and square. So 8k square 64k square, 15 square 225, and k square as it is. So 225k square. Now add these two numbers, so you get 289k square, and take square root. So 289 square root is equals to 17. So 17k. So your third side hypotenuse is 17k. Now sine A. Sine A, opposite, that means BC upon hypotenuse, it's AC. So put the value of BC and AC, 15k upon 17k. So your kk cut. So finally you got 15 upon 17, right? Then second thing, sec A. Sec A is equals to formula of sec. It is a hypotenuse, that means AC upon adjacent with respect to A. It's a AB. So 17k upon 8k, kk cut. So finally you got 17 by 8, right? Now second method. From cot theta we can find tan theta. It is inverse of cot theta. So change the numerator and denominator, that means 15 by 8. And from tan theta you can find sec theta. We learned this formula. Sec theta is equal to, because sec square theta is equal to 1 plus tan square theta. So square root of it 1 plus tan square theta. We already learned this formula in our theory part. Now put the value. So 1 plus and tan square theta, this is tan theta, and now find out that square of tan theta. So 15 square 225 and 8 square 64, right? Then take the LCM. So 64 ones are 64 plus 225. So you got 289 upon 64. Now take square root. So 289 square root 70 and square root of 64, it is 8. So sec A you got here, sorry, in place of theta we need to write A. So sec A you got 17 by 8, right? So sec A is equals to 17 by 8. Now from sec A you can find cos A, because cos is inverse of sec. So again change the numerator and denominator of sec A. So you got 8 upon 17. And then for sine A, formula is 1 minus cos square A. If you don't know this formula, then see my video, that is a theory part 2. I already mentioned this all formula in that video. Okay. Now put the value. Now cos square. So 8 square 64 and denominator 17 square 289. Again simplify it. So 289 ones are 289 minus 64. So 225 upon 289. Now take square root. So it is a square root of 225 15 and square root of 289 17. So you got answer 15 by 17. Okay. Question number 5. Given sec theta is equals to 13 by 12, calculate all other trigonometric ratios. One value is given, we need to find other trigonometric ratio, that means sine theta, cos theta, tan theta, cosec theta, cot theta. Okay, so here our second method is somehow difficult. So we are going with only our first way, that is triangle method. So first of all, make one triangle and here theta is given. So you can give any name to our triangle A, B and C. Any angle you can take as a 90 degree. Okay, and give one angle to the theta. Give theta value to one angle. Then sec theta is equals to 13 by 12. What is the formula of sec theta? Hypotenuse upon adjacent. So give hypotenuse, that means AC is equals to 13k, and denominator adjacent. Adjacent side for theta it's AB. So give 12k to AB, and find out third side BC by Pythagoras theorem. So what is Pythagoras theorem? Hypotenuse AC square is equals to AB square plus BC square. Here we need to find BC. So BC as it is, transfer AB to the left hand side. So AC square minus AB square is equals to BC square, and take square root from both the side. So AC square root of AC square minus AB square is equals to BC. Square root of BC square is equals to BC. So this formula we use here. BC is equals to under root AC square minus AB square. Now put the value of AC, it's a 13k, and put value of AB, it's a 12k. Now 13 square 169k square, 12k square 144k square, and subtract it, 169 minus 144, so 25k square, and square root of 25k square is equals to 5k. So our third side BC is equals to 5k. Now start with sine theta. Sine theta, opposite side BC upon hypotenuse AC. So opposite side BC is equals to 5k upon hypotenuse AC is equals to 13k. K cut, so 5 upon 13 sine theta. Okay, then cos theta. Cos theta is equals to adjacent side upon hypotenuse. So AB upon AC. So 12k upon 13k, k cut, so 12 upon 13. Then tan theta. Formula of tan theta is equals to opposite upon adjacent, opposite upon adjacent, right? So opposite BC upon adjacent AB. So 5k upon 12k, k cut, so 5 upon 12. Then cot theta. We can directly find cot theta. Inverse of tan. Tan theta is equals to 5 upon 12. Change the numerator denominator. So 12 upon 5 directly. Same way we can find cosec theta from sin theta, because cosec theta is inverse of sin theta. So our sin theta is equals to 5 upon 13. If we inverse this answer, that means change the numerator and denominator, we can get our cosec theta. So sin theta is equals to 5 upon 13. So our cosec theta is equals to 13 by 5.